Now that we found the eigenvalues using characteristic polynomial here, we need to move on and find the eigenvectors associated to each one of them. So I'm going to keep this guy on the left side and lambda equals to -2 on the other side. So theorem says to find the eigenvectors, you need to solve this equation. Lambda times I minus a times x equal to 0. So here you have -1 times 1, 0, 0, 1, which is your identity matrix, minus matrix A, which is given to you as 2, -12, 1, and -5, times x equal to 0. Perfect. So we get -1, 0, 0, -1, minus 2, -12, 1, and -5, times x equal to 0. Basically, we have -1 minus 2, -3, and -1 plus 12, which is 11. Then here you have -1 and -1 plus 5, which is 4. Oh, it should be just 12, am I right? Yeah, because it's just 0. Perfect. Times x equal to 0. Or basically, we are saying that we have -3, -1, 12, 4, x and y equal to 0 and 0. Well, here you can multiply this or reduce this matrix as well, because it doesn't matter if you leave it as it is or reduce the matrix. Both of them give you the exact same result. -3x plus 12y is 0, -x plus 4y is equal to 0. So basically, they're saying that, hey, if I multiply the first equation by a third or second equation by 3, I get the exact same result. So what's the meaning of that? It means that, hey, y or x is equal to 4y. If I substitute this guy here, -12y plus 12y is equal to 0. 0 is always equal to 0, so the system is consistent with infinitely many solutions. So basically, we are saying that, hey, if I want to write this in terms of, for example, a new parameter like t, I have the following. So reduce this as well, makes it more suitable for us. So you have -3, 12, -1, and 4, which is basically the same as, if I divide by 3, you get 1. And here you have -4, and this guy becomes 0, and this guy becomes also 0. xy equal to 0, 0. So suppose y is equal to t, so x becomes 4t. All vectors related to eigenvalue -1 are in the form of t, parenthesis, 4 and 1. So let's just circle this. These are your eigenvectors for eigenvalue negative. You can do the exact same process for lambda equals to -2. Do the exact same thing. Here you have -2 times 1, 0, 0, 1 minus matrix A, which is 2, 1, -12, and -5 times x equal to 0. -2, 0, 0, and -2 minus 2, -12, 1, and -5 times x equal to 0. So basically you have -2, -2, -4, and then you have 0, 12, and then here you have -1, -2 plus 5, 3 times x and y equals to 0 and 0. Doing the exact same thing, this guy is equivalent to, if I divide by -4, I get 1, -3, I have -1 and 3, which is 0 and 0. X and y equal to 0 and 0. So suppose y is equal to t or s. If you want to use a different parameter, absolutely fine. You get x equals to 3s. So all the vectors associated to lambda equals to -2 are in the form of s, 3, and 1. These are your eigenvectors. For eigenvalue, -2.